Hello. Today, we'll explore how a quadratic function, which graphs as a parabola, relates to the x-axis. A quadratic equation has the general form y equals ax squared plus bx plus c. The position of the parabola relative to the x-axis depends on two key things: the sign of which tells us if the parabola opens upwards or downwards, and the value of the discriminant, which is b squared minus 4ac. First, let's consider when the parabola is tangent to the x-axis. This means it touches the x-axis at exactly one point, which is the vertex of the parabola. This happens when the discriminant is equal to 0. In this case, the quadratic equation has exactly one real root, often called a repeated or double root. Let's look at an example. Consider y equals x squared minus 4x plus 4. Here, a is 1, b is minus 4, and c is 4. The discriminant is minus 4 squared minus 4 times 1 times 4, which equals 16 minus 16, or 0. Since it is positive, the parabola opens upwards and touches the x-axis at x equals 2. If it were negative, say y equals minus x squared plus 6x minus 9, the discriminant is still 0, but the parabola opens downwards, touching the x-axis at x equals 3. Second, the parabola might be entirely above or entirely below the x-axis, never touching or crossing it. This occurs when the discriminant is negative. In this situation, the quadratic equation has no real roots. Its roots are complex. If I is positive and the discriminant is negative, the parabola opens upwards and stays entirely above the x-axis. For example, y equals x squared plus 2x plus 3. The discriminant is 2 squared minus 4 times 1 times 3, which is 4 minus 12, or negative 8. Since it is positive and the discriminant is negative, the graph is always above the x-axis. Conversely, if I is negative and the discriminant is negative, the parabola opens downwards and stays entirely below the x-axis. Consider y equals negative x squared minus x minus 1. The discriminant is negative 1 squared minus 4 times negative 1 times negative 1, which is 1 minus 4, or negative 3. Since it is negative and the discriminant is negative, the graph is always below the x-axis. Finally, the third case is when the parabola crosses the x-axis at two distinct points. This happens when the discriminant is positive. In this scenario, the quadratic equation has two distinct real roots which correspond to the x-intercepts of the parabola. For example, y equals x squared minus 5x plus 4. The discriminant is negative 5 squared minus 4 times 1 times 4, which is 25 minus 16, or 9. Since the discriminant is positive and it is positive, the parabola opens upwards and crosses the x-axis twice, at x equals 1 and x equals 4. If it is negative, like y equals negative x squared plus x plus 2, the discriminant is 1 squared minus 4 times negative 1 times 2, which is 1 plus 8, or 9. Since the discriminant is positive and it is negative, the parabola opens downwards and crosses the x-axis twice, at x equals minus 1 and x equals 2. Let's summarize these findings in a table. When the discriminant is 0, the parabola is tangent to the x-axis, and there's one real root. When the discriminant is negative, the parabola is entirely above or below the x-axis, and there are no real roots. The position, above or below, depends on the sign of I. When the discriminant is positive, the parabola crosses the x-axis at 2 points, and there are two distinct real roots. So, by calculating the discriminant and checking the sign of, we can quickly determine how the graph of any quadratic function relates to the x-axis without needing to fully graph it. This is a powerful tool in understanding quadratic equations.